Hello guys, I'm Jose Alvaro from ECE31. For today's vlog is about experiment 3, the exclusive OR and exclusive NOR gate. The objective of this experiment is to familiarize the students with the basic operations of two-input exclusive OR and exclusive NOR gate, and to be able to understand the basic applications of XOR Gate. So, watch and enjoy! Here are the materials that we will be using. For the first part of the experiment, examining the basic operations of XOR Gate, we use the 7486 quadruple 2-input exclusive OR gate. We connect the third pin of the XOR gate to the resistor in series with the LED followed by the ground. Then, the 7th pin of the IC to the ground. For the inputs A and B, we connect the wires to the first and second pin of the XOR gate. Then, the VCC to the source and the positive and negative terminal of the power supply. For both inputs of 0, the output will be off. Then, put the input B to 1, the output will be on. If the input is 1 and 0, the output will be on. If both inputs are 1, the output will be off. And here are the results. For the second part of the experiment is the basic operations of XNOR Gate. We will be using 74266 IC. For the inputs, A and B is connected to the first and second pin of the IC. Then, we place the resistor to the third pin of the IC to the VCC. Then, we place the LED in series with the resistor, then the ground. The 7th pin of the XNOR gate is connected to the ground. We connect the positive and negative terminals of the power supply. If the inputs are both 0, the output will be on. Then we put the input B to 1, the output will be off. For the inputs of 1 and 0, the output will be off. If both inputs are 1, the output will be on. Here are the results. For the single direction DC motor control, we will be using a 12-volt DC motor, and we will determine from what inputs will have an output of 1 or be in an on state. The circuit uses a 12 volts power supply and a XOR gate, diode, and a transistor. By following the circuit diagram, we will be coming up with a circuit of single direction DC motor control. If the inputs are both 0, the output is off. If the inputs are 0 and 1, the output is on. If the inputs are 1 and 0, the output is on. If both inputs are 1, the output is off. And here are the results. For the half-adder circuit, we have two outputs which are S and C. The S output will be the yellow LED, and for the C output will be the blue LED. For the circuit, we will be using 7486 exclusive OR gate and 7408 AND gate. We place the XOR gate and the AND gate respectively. Then, we put the 360 ohm resistor to the third pin of the XOR gate and the LED in series. Then another 360 ohm resistor for the AND gate, followed by the LED connected in series. We connect both first pin of the ICs to each other as input B. Then, we connect the second pin of both ICs as our input A. Then, we put proper grounding into the circuit. The VCC to the source, and the positive and negative terminals of the power supply. For inputs A and B are 0, both outputs will be off. Then, we put the input B to 1, only the output S is on, while the C is off. For inputs of 1 and 0, only the output S is on. For both inputs of 1, the output C will be on. Here are the results. For the first part of the experiment, basic operations of XOR gate. Based on the results of the experiment, we can notice that when using the XOR gate, if the inputs for A and B were the same, like input A is 1 and input B is 1, the output would be 0. If the inputs were different, the output would be on or equals to logic 1. For the basic operations of XNOR Gate, based on the results of data, the output would be on or logic 1 if the inputs were the same, and it will be off or logic 0 if the inputs are not the same. The operation of XNOR is opposite to the operations of XOR Gate. We can say that the operations using exclusive NOR gate is a complement of the XOR Gate operations. For the half-adder circuit, it has 2 inputs and 2 outputs as well. It means that for the half-adder circuit, it is a combinational circuit, wherein the 2 inputs and outputs of the circuit is located at different IC used, such as the XOR gate and the AND gate. Based on the result of the half-adder circuit, the output S would be in an on state if the 2 inputs are different or does not have the same inputs, and the output C would be in an on state only if the inputs are both 1.